Okay, hi everyone. We're group 53, and we had the treasure chest problem. So the problem reads, a filled treasure chest with a mass of 375 kilograms with a long rope tied around its center lies in the middle of a room. A pirate wishes to drag the chest, but there's friction between the chest and the floor, with coefficient of static friction equaling 0.52. The angle between the rope and the floor is 30 degrees. Make a free body diagram and find the necessary tension required to just get the chest moving. So I've listed our knowns over here. We have the static friction coefficient, we have the mass, we know gravity, we're looking for the tension, and we know theta. So this is our free body diagram over here. We have the tension, which is at an angle of 30 degrees. We have normal force, we have gravity, and we have the frictional force opposing the motion. So this tension force also has its vertical components. So we have T sine theta, and we have T cosine theta. So in order to move an object that's standing still, you must overcome the friction max, and the equation for that is the coefficient of friction times the normal force. And if the object had been just pulled up with at a 90-degree angle, we could just say the normal force is mass times gravity. But in this case, the normal force is mass times gravity minus the vertical component of the tension, because that tension is taking some of that force off. So we can plug this into our F max formula. And so now we know the equation to find the maximum friction that we need to overcome. And so we're going to overcome that with this horizontal component of the tension. So we can set this whole equation equal to this side. Now when we rearrange this equation, oh, I forgot T. When we rearrange this equation to solve for T, we get the coefficient times mass times gravity all over cosine theta plus sine theta mu sub s. So now all we have to do is plug in our knowns. We have 0.52, 375 kilograms, 9.8 meters per second squared, all over cosine 30 plus the coefficient times sine 30. And this gives us about 16.97, and with sig figs, that's 1700